Today, we're dissecting how DeepSeek just destroyed every assumption about AI development, not the polite, impressive research takes, but the brutal reality where a Chinese startup with a fraction of the budget just made GPT-4 look expensive, where reinforcement learning from human feedback went from academic curiosity to production necessity, and where every AI company is frantically rewriting their roadmaps. Three experts who watched the industry get blindsided, saw billion-dollar valuations evaporate overnight, and learned why sometimes the best engineering comes from constraints, not resources. I'm Sam, and someone just asked me why our $100 million foundation model project looks obsolete after one paper.
I watched DeepSeek's release from the inside of the AI industry. The reaction wasn't just surprise, it was existential panic. They achieved GPT-4 level performance with a fraction of the compute budget and completely open-sourced everything. Broke our assumptions about what was possible with limited resources and showed that clever engineering beats throwing money at problems. The entire industry had to reckon with the fact that we might have been doing this wrong.
I've been implementing reinforcement learning systems for 3 years, watching it slowly creep into production workflows. DeepSeek didn't just use RL, they showed how to make it practical, scalable, and integral to model development. Before DeepSeek, RL was this finicky research technique that broke more often than it worked. Now it's becoming table stakes for competitive AI models. The infrastructure implications are massive.
I've guided dozens of AI companies through strategic pivots, but nothing prepared me for the DeepSeek moment. In one release, they demonstrated that the entire Western AI industry's approach massive compute, closed development, billion-dollar budgets wasn't the only path to state-of-the-art results. The implications go far beyond just one model. They've changed the fundamental economics of AI development.
Dr. Martinez, guide us through this industry earthquake. Lisa and Marcus, prepare to explain why "we just need more compute" became the most expensive lie in AI development. No mercy, no hand-waving about different evaluation metrics.
Let's start with the shock. What exactly did DeepSeek do that stunned the AI world?
They achieved competitive performance with GPT-4 using dramatically less compute, open-sourced everything including training details, and showed that reinforcement learning could be practically applied at scale. But the real shock was the efficiency. They proved that clever architecture choices and training strategies could overcome raw computational brute force. It challenged the entire scaling paradigm the industry was built on.
The reinforcement learning integration was the technical breakthrough. Most companies treat RL as a post-training fine-tuning step. DeepSeek made it integral to the entire training process. They showed how to make RL stable, scalable, and practical for foundation model development. This wasn't academic RL that works in simulations. This was production RL that works on real human feedback at massive scale.
Why was this such a surprise to the industry? What assumptions did it break?
The scaling law orthodoxy. The industry believed that better models required exponentially more compute, data, and money. DeepSeek showed that engineering innovation could achieve similar results with dramatically fewer resources. Broke the assumption that only big tech companies with unlimited budgets could build competitive foundation models. Suddenly, every AI company's competitive moat looked questionable.
And the complexity assumption about RL. Everyone thought reinforcement learning was too unstable, too complex, and too resource-intensive for production use. DeepSeek proved that with the right engineering, RL could be more reliable and effective than traditional training methods. They made the impossible look routine.
Walk me through the technical innovations. What specifically made DeepSeek different?
Mixture of experts' architecture for efficiency, novel attention mechanisms for better scaling, and most importantly, sophisticated reinforcement learning from human feedback throughout the training process. They didn't just add RL at the end, they integrated human preference optimization into the core training loop. This required completely rethinking model architecture, data pipelines, and training infrastructure.
How does this change the reinforcement learning landscape in AI development?
RL went from optional enhancement to mandatory capability. Before DeepSeek, companies could build competitive models with supervised learning alone. Now, if you're not doing sophisticated RL, you're at a significant disadvantage. It's like the moment when transformer attention mechanisms became essential. You either adapt or become obsolete.
And the infrastructure requirements exploded. RL training is fundamentally different from supervised learning. You need human feedback loops, reward modeling, policy optimization, and stability guarantees. Companies that were barely handling supervised learning at scale now need to build entirely new training pipelines. The engineering complexity increased by an order of magnitude.
What are the practical implications for companies trying to implement RL in their AI development?
You need completely different infrastructure. RL requires online learning capabilities, human-in-the-loop feedback systems, reward model training, and policy optimization at scale. Most companies have supervised learning pipelines that can't handle the interactive, iterative nature of RL training. You're basically rebuilding your entire ML infrastructure from scratch.
New expertise requirements. RL is notoriously finicky, hyperparameter sensitive, unstable, and difficult to debug. You need engineers who understand not just machine learning, but control theory, optimization, and human psychology. The talent requirements are completely different from traditional ML engineering.
How did the industry react to DeepSeek's release?
Initial disbelief, then panic, then frantic scrambling. Companies that had spent hundreds of millions on compute-heavy approaches suddenly realized they might be fundamentally inefficient. There was a rush to reverse engineer DeepSeek's methods, hire RL experts, and redesign training pipelines. Some companies started completely over rather than try to adapt existing systems.
What does this mean for the competitive landscape in AI?
It democratized high-performance AI development. Before DeepSeek, only companies with massive compute budgets could compete. Now, clever engineering and innovative approaches can level the playing field. This is great for innovation, but terrifying for companies whose entire competitive advantage was based on having more resources than their competitors.
How do you actually implement RL in production AI systems?
Start with reward modeling. You need systems to capture and encode human preferences. Then build policy optimization pipelines that can handle the iterative nature of RL training. You need robust evaluation frameworks because RL can be unstable. And most importantly, you need infrastructure that can handle the feedback loops between human annotators, reward models, and policy training.
What are the biggest challenges companies face when adopting RL?
Sample efficiency and stability. RL requires enormous amounts of interaction data and can be incredibly unstable. Small changes in hyperparameters or training procedures can cause complete failure. You need sophisticated monitoring, checkpointing, and recovery systems. Most companies underestimate the engineering complexity required to make RL work reliably.
Human feedback quality and scalability. RL depends on high-quality human preferences, but human annotation is expensive, inconsistent, and doesn't scale well. You need sophisticated systems to collect, validate, and utilize human feedback effectively. Bad feedback data destroys RL performance more than bad training data destroys supervised learning.
How has DeepSeek changed the economics of AI development?
Proved that efficiency innovations can be more valuable than scale increases. Companies that were planning to spend hundreds of millions on compute are now investing in research and engineering instead. The cost of achieving state-of-the-art performance dropped dramatically, which is great for innovation but terrible for companies whose business models depended on high barriers to entry.
What about the open source implications?
DeepSeek open-sourced everything: model weights, training code, data processing pipelines. This accelerated innovation across the entire industry, but also commoditized what were previously competitive advantages. Companies can no longer rely on keeping their training methods secret. Competitive advantage shifted from proprietary techniques to execution quality and application-specific optimization.
How do you evaluate and compare RL-trained models?
Traditional benchmarks don't capture RL improvements well. You need human preference evaluations, multi-turn conversation quality, and task-specific performance metrics. RL-trained models often perform better on subjective qualities like helpfulness and safety, which are harder to measure but more important for real applications. Evaluation becomes much more complex and expensive.
What does the future look like for RL in AI development?
RL becomes standard practice, not experimental technique. We'll see more sophisticated reward modeling, multi-objective optimization, and integration with other training methods. The infrastructure will mature and become more accessible. Eventually, training models without RL will seem as outdated as training without attention mechanisms.
How should companies adapt their AI strategies post-DeepSeek?
Focus on engineering innovation over resource accumulation. Invest in RL capabilities and human feedback systems. Build teams that can iterate quickly rather than just throw compute at problems. The companies that adapt fastest to the efficiency-focused paradigm will have significant advantages over those still stuck in the scaling law mindset.
What are the geopolitical implications of DeepSeek's breakthrough?
It showed that AI leadership isn't guaranteed by having the most compute or the biggest budget. Chinese companies demonstrated they could achieve comparable results with different approaches and constraints. This challenges assumptions about technological superiority and highlights that innovation can come from anywhere. The AI race became much more competitive and unpredictable.
How do you debug and troubleshoot RL training issues?
RL debugging is much harder than supervised learning. You need to monitor reward signals, policy gradients, value function estimates, and exploration patterns. Small bugs can cause catastrophic training failures or subtle performance degradation. You need sophisticated logging, visualization tools, and statistical analysis to understand what's happening during training.
So DeepSeek didn't just release a good model, they completely rewrote the rules of AI development, proved that engineering innovation beats resource accumulation, and made reinforcement learning from academic curiosity to production necessity. This isn't just a technical breakthrough, it's an entire industry paradigm shift.
Welcome to the post-DeepSeek era. Anyone can train a transformer, but building efficient, RL-enhanced models that compete with billion-dollar systems using a fraction of the resources. That requires rethinking everything we thought we knew about AI development. The scaling laws just got rewritten.
This episode was brought to you by Engineer Panic, where we expose how single breakthroughs can demolish entire industry assumptions. Because understanding why your $100 million foundation model project looks obsolete might be more important than your benchmark scores. We're back. Let's talk about the practical nightmare of adapting to the post-DeepSeek reality. Lisa, what's the most urgent advice for AI companies right now?
Start experimenting with RL immediately, even if it's just small-scale pilots. The learning curve is steep, and waiting until your competitors have figured it out puts you at a massive disadvantage. Also, question all your scaling assumptions. Efficiency innovations might be more valuable than hardware upgrades.
Invest in human feedback infrastructure. RL requires high-quality human annotations at scale, which means building systems for collecting, validating, and utilizing human preferences. This isn't just an ML problem, it's a product and operations problem. Start building these capabilities now.
Hire people who understand both the theory and practice of RL. The talent pool is small and demand just exploded. Don't try to retrain your supervised learning engineers overnight. RL requires fundamentally different intuitions and debugging skills.
What are the biggest mistakes companies are making in response to DeepSeek?
Trying to copy DeepSeek exactly instead of understanding the principles. Every company's data, infrastructure, and use cases are different. You need to adapt the innovations to your specific context, not just replicate their exact setup. Also, underestimating the engineering complexity of making RL work reliably.
Rushing into RL without proper infrastructure. Companies are adding RL to existing training pipelines that weren't designed for it. You need to rebuild your entire training infrastructure to handle the interactive, iterative nature of RL. Half measures lead to frustrating failures.
Panicking and throwing out everything that was working. DeepSeek showed new possibilities, but that doesn't mean every existing approach is wrong. The key is intelligent integration of new techniques with proven methods, not wholesale replacement.
How do you measure ROI on RL investments?
Focus on model quality improvements that matter for your specific use cases. RL often improves subjective qualities like helpfulness, safety, and user satisfaction that don't show up in traditional benchmarks. Measure what actually matters for your product, not just what's easy to measure.
What keeps you up at night about the post-DeepSeek landscape?
The complexity explosion. RL makes everything harder: training, evaluation, debugging, and deployment. We're adding enormous complexity to already complex systems. I worry about the sustainability and reliability of these increasingly sophisticated training pipelines.
The talent shortage getting worse. Every AI company now needs RL expertise, but there aren't enough people who understand both the theory and practice. This creates huge knowledge gaps and increases the risk of poorly implemented RL systems that look good in demos but fail in production.
The democratization of powerful AI capabilities. DeepSeek showed that sophisticated AI development is no longer limited to big tech companies. This is great for innovation, but creates new challenges around safety, regulation, and responsible development at scale.
How do you future-proof AI development strategies after DeepSeek?
Build flexible, modular training infrastructure that can adapt to new techniques. Don't hard-code specific approaches, create systems that can incorporate new training methods as they emerge. The only constant is that training techniques will keep evolving rapidly.
Final advice for teams navigating the post-DeepSeek AI landscape.
Embrace the paradigm shift. DeepSeek proved that efficiency and innovation matter more than resources. Focus on building teams that can iterate quickly, experiment effectively, and adapt to new techniques. The companies that learn fastest will win.
Invest in foundational capabilities, human feedback systems, flexible training infrastructure, and RL expertise. These aren't optional nice-to-haves anymore, they're competitive necessities. Start building these capabilities now, even if they seem complex or expensive.
Question everything you think you know about AI development. DeepSeek showed that breakthrough innovations can come from unexpected places and challenge fundamental assumptions. Stay humble, stay curious, and be ready to rebuild when paradigms shift.
This has been Engineer Panic. We've learned that DeepSeek didn't just release a model, they rewrote the rules of AI development, made RL essential for competitive performance, and proved that engineering innovation beats resource accumulation. Sweet dreams, and may your training runs be stable and your human feedback be high quality.
Thanks for the reality check. Now, if you'll excuse me, I need to figure out why our new RL training pipeline is producing models that are helpful in completely unexpected ways, and whether that's a feature or a bug.
And I need to explain to my team why we're rebuilding our entire training infrastructure for the third time this year, and why our compute budget just doubled even though we're supposed to be more efficient now.
Keep building, keep adapting, and keep questioning your assumptions. The future belongs to teams that can turn constraints into innovations and adapt quickly when the entire industry paradigm shifts overnight.
This has been Engineer Panic, where breakthrough innovations meet industry reality. Until next time, remember, your AI strategy isn't failing because it's technically wrong. It's failing because the rules just changed completely. Adapt or become obsolete.